Hi everyone and welcome to another episode of Gaffer and Gear. This is a very quick episode about a very important firmware update that you need to put into your 1200Ds if you're looking to shoot anything at high speed. So when I say high speed, I'm not talking a couple of hundred frames per second, we're talking thousands of frames per second. You need to put the latest firmware update in. Alright, so let me give you a bit of a backstory. So I had a shoot at 1000 FPS with a robotic camera with a phantom camera system on it. And we had problems with flicker with these lights, with the release software that came with them. Now, according to my frequency meter here, this light with its release software should be flicker-free at 1000 FPS. According to the meter, it should be flicker-free at 10,000 FPS even. Now, at 1000 FPS, with the frequency selector maxed out, the frequency meter was telling me that I've only got a 0.5% chance of getting flicker. Now, Aputure also told me that the light is flicker-free at these frame rates. So here was the problem. 1000 frames per second on set, this thing flickered like crazy. It was actually unusable. Now, at 100% brightness, it was okay, but as soon as you touch the dimmer, it flickers to the point of being embarrassing. So anyway, after a lot of video messages going back and forth between me and Aputure and my contact at Aputure talking directly to the engineers, everyone was to the conclusion that the problem was definitely with the lights. It wasn't the camera settings or anything like that. It was 100% the light. Now, I already knew this because I had replaced the light with a different brand and the flicker issue had gone away. In fact, I had 7 other different types of lights on that set, including other Aputures, and nothing else was flickering on the camera settings. So I 100% knew it was these. All right, so what's changed? Aputure have put out a firmware update since to address this problem. With the new firmware, you go into the menu system and you'll see a picture of a camera with high speed mode. Click on that and you can turn the high speed mode on and off. Now, if you select on, this light is not just flicker free at 1000 FPS, it is flicker free at every single frame rate you can dial in. It doesn't matter what shutter speed you are shooting at. This light is now infinitely flicker-free, but it does come at a cost. You can't dim it below 50% brightness, which we'll talk about in a sec. All right, so what's the magical trick Aputure have done here? Well, when they built the controller, they put in a backup redundancy dimmer system that works in a different way. So you're probably thinking, thank God Aputure had the foresight to put a backup redundancy system into the light. Well, Aputure aren't the only manufacturers to do things like this. A lot of other manufacturers, particularly the more expensive manufacturers, do put redundancies into their lights. And here's why. Here's something to think about. An LED light engine has an average lifespan of 50,000 hours. All right, so let's say I'm doing a gear review and I want to test if this light is going to last 50,000 hours. No problem at all. Here's what I'll do. I'll set it up here, turn it on, and just run it until we get to 50,000 hours. How long do you reckon that's going to take? Well, I've done the maths. 5.7 years. Now, can you imagine if every manufacturer of lights, every step along the way in the evolution, waited 5.7 years to thoroughly test their lights before releasing it? We would probably only just be getting into RGB lights now. All right, so the best insurance policy that manufacturers have to cover themselves if anything goes wrong with the light into the future, because they can't test them for 5.7 years, is to put backup and redundancy hardware into the lights and have that be able to turn on with a firmware adjustment. All right, so I've got the whiteboard out. So what that means is 90% of you can turn off the video now, because all you need to know really is that you can press a button on the menu system and you won't have flicker issues. But for those of you who are curious as to what the magical solution is, I'm going to explain the 2 dimmer systems. Now, these are the 2 most common dimmer systems that you come across in LED lights. All right, so the first dimmer system is pulse width modulation, so PWC. So I'm going to do a really bad drawing here to show how it works. All right, so we've got our light and it's pulsing at super high frequency. So there's a pulse, okay, there's a gap, there's a pulse, there's a gap, there's a pulse, there's a gap, there's a pulse. All right, so with pulse width modulation, what determines the brightness is the thickness of the gaps between the pulses. So if you've got 50% gaps and 50% pulses, the light is running at 50% brightness. Now here's the problem. The more you dim the pulse width modulation system, the bigger the gaps between the pulses. So it either reduces the amount of pulses or it reduces the duration of each pulse, or a combination of both. All right, so this can lead to flicker. Now what causes flicker isn't the pulses, okay? It's the gaps between the pulses that causes the flicker. Now the other type of dimming system that's in this light, and is also common in other LEDs, is called potentiometer dimming, or constant current dimming. Now I'm not going to bother trying to write potentiometer because I will spell that wrong. All right, so with potentiometer dimming, it works by reducing the voltage going to the LEDs. So we've got a light running at 100% brightness, and we want to reduce it to 50% brightness. The potentiometer just reduces the current, or sorry, the voltage, down to 50%. Okay, so that's how it works. All right, so this system here is very predominant in cheaper LED lights. So that's something I found through my gear reviews here. Now this does have one advantage. Because there are no gaps anywhere at all here, it's completely continuous. There is no flicker at all. No flicker whatsoever in this system. But it does have a few issues. And this is what I found through testing hundreds of lights here with a spectrometer. All right, so at 100% brightness, awesome. Down to about 50% brightness, awesome. But between 50% and usually around 15%, the light starts to skew towards magenta. So that's what I found testing hundreds of lights that have this system. All right. Now, when you get below about 10%, so 10% and below, they start to skew towards green. So that's one of the problems with this system. You get a lot of skewing in the colors, but you don't get that on pulse width modulation because the light technically is always running at 100%. All right, it's just the gaps that determine the lack of brightness, or how bright the unit is. Now, the other problem with potentiometer dimming is the lifespan of the LEDs. All right, because you're reducing the voltage going to the LEDs, or reducing the voltage going to components that run the LEDs, you are reducing the life cycle of those components or the LEDs, because they're designed to work at a specific voltage, and changing that voltage isn't good for them. So we're talking with some lights, they don't run 50,000 hours with this system like they do with pulse width modulation. They might only run 20,000 hours or 30,000 hours. All right, so just to be clear, when the light is running in its normal mode, it's running in pulse width modulation. That should be an M. Pulse width modulation. Okay, so in its normal mode, it's running in pulse width modulation, and in its high speed mode, it is running in potentiometer. That is why in the high speed mode, the light does not run below 50%, because below 50%, you start getting all those issues. All right, hopefully that made sense. See you on the next episode of Gaffer in Gear.